Okay, good morning, everybody. Welcome back to our training workshop. Yesterday was a very good day. We had lots of interesting presentations, lots of useful information on the livestock emissions from Eswatini, and we're going to continue that today. We'll be first having an interactive session with the farm level glean tool that Armando introduced yesterday. And we'll then focus on data needs and data gaps and data collection and some recommendations for how to proceed with that. And then the third section of the day will be about looking at mitigation options. But first, I'm going to hand over to Armando, who is going to guide us through some interactive questioning. Armando.
Hello, everyone. Thank you, Tim. Just want to put the rules, as you can see now on the screen, are the rules of the workshop. I really want to know if you have some questions or you have some comments you can put on the chat, and we can go through the comments at any time that we have the presentations. With that in mind, we really want to have a feedback about what happened or how you received yesterday presentations. So there is a little quiz, a little poll that you can. It's going to be interactive right now. So there's going to be some questions coming to the screen, and then I want you that you answer according to what you understood. I really want that all the participants are now active and try to fill the pool in order to know exactly what you get from yesterday, and at the end we can get some feedback and some explanation about the questions. So with that, let me launch. There are gonna be 4 questions, so it's gonna be time that you can answer right now. Please, here it is. You can see now the pool.
Yes.
Okay, please. Please try to fill the question. For example, the first question is, what are the 4 agroecological zones of Eswatini? I think this is going to be a really easy one, but I want to know exactly what is the interaction from the participants today. The second question is, what is the source of greenhouse emission in the livestock sector? You have then several answers. You can choose this one. The third question is, what is glean? According to the presentation yesterday. And the last question and the fourth one is, why move to a tier 2 method? So please try to participate and fill and answer the questions. Then we'll know exactly how many people were interacting right now. We can give probably around 2 minutes for that, and then we can go in for the answers. I don't know. Probably can you see the answers live that when it's filling, or I can
see the answers live.
Okay, thank you.
But I'm a co-host, and I wasn't able to put my own answers in.
Oh yes, I know.
It's maybe a host's view.
Okay, perfect. And after this poll, I want to encourage the people, if they can have some ideas. I mean, they can just open the microphone and tell us how you think that it was the participation or the presentation yesterday, if it was really clear what we were explaining. or if there is some comments, then we can probably make more interactive today our sessions, and then we can get much better feedback from you from this session too. So right now I can see that we had that 40%, almost 50% of the people who are in this meeting answered the questions. So probably it will be nice if the rest can answer the questions. It's not important if it's the right one. You don't have to check some information now. It's just about what you took from yesterday, from the information that we were presenting.
Armando, some of us who are co-hosts won't be able to answer the question, so that's
yes,
a bit more.
Okay.
Not sure how many of us are co-hosts. Three of us, in fact.
Yeah.
Rex Brown is saying that he doesn't see any questions.
It's on the, it's a poll that is right now in that pop up, so probably I don't know. Could you?
Yeah, I was able to do the poll. Rex, did it not pop up on your screen?
Okay, Amanda, I think that's
No,
what
it
Okay.
didn't.
we're going to get.
Yeah, perfect. So let me go through
But
the.
not a worry.
No,
Hello, can you hear me?
Hello, Rex.
Okay, so let me go through the questions and give some feedback and some ideas of what happened yesterday. Okay, yesterday we have a really important sessions where they're explaining what is the situation of Eswatini about the livestock sector, how they are. There was a presentation about where is the production system located, about the agroecological zone that we're defining for the country, about some data set about export, imports, and then we have another different presentation about GLIM. So we know exactly what was able GLIM to do for Eswatini, for the livestock sector. So about the first question here, what are the four agroecological zones of Eswatini? I think that 100% of the people who answer were right. Is the Highveld, the Middlebelt, the Lowveld, and Lubombo. What was this important from yesterday?
Armando,
Because,
Armando, please. Excuse me, Armando, can you please put the result of the poll on the screen so we can see?
Okay, let me
if
see.
possible. So I think it's important that all participants see the answers.
Yeah, then share results.
Share results.
Can
I think you
everybody
can see
that
now. Yep. Could you confirm if you can see the answers now?
Yes, we can
Okay,
see.
perfect. Yeah. So how I was explaining what is important to know exactly what and for people who are from outside from Eswatini, it's important to know that the high well, the middle well, the low well, and Lubombo had their specific the specific characteristics for a different production on each one. So according to that, it was defining the production systems because the feed basket that is given to the animals in the high well is totally different than what is given in the low well. So that is the importance to define exactly what are the different areas where we can characterize, make a characterization of the different production in Eswatini. The second question was, what are the source of greenhouse emission in the livestock sector? We have methane, nitrous oxide, carbon dioxide, and all of them are part of the greenhouse emissions. From the direct emissions, we have methane coming from enteric fermentation. We have methane producing in the manure management as a gas. The nitrous oxide is produced in the manure management, and the carbon dioxide is producing about the transportation and different activities that is going in the livestock value chain. And the third question is, what is GLIM? I think that 89% of the people were answering right. That is, it's a GIS tool that is helping us to estimate greenhouse emission in the livestock supply chain. So it's calculating everything in a tier 2 level. So that is the important about using GLIM, because GLIM gave us the opportunity to make simulations about what are the scenarios if we implement a different activities or different actions or mitigation actions, and then we can have we have a simulation or calculations of what is the impact of this mitigation action into the greenhouse emissions. So it's important, and it's a really useful tool where we can totally know exactly what are the effects on the greenhouse emissions when we are implementing different mitigation actions, for example. Why move to a tier 2 method? That is important. I think that the three listed here, and everyone was answering good, is it gives us more detail about what is the classification of animals. So it's one of the advantages of using a tier 2 level. It's not using, like, for example, as difference at tier 1, when we use just one emission factor and then we multiply that by the total population of livestock, and the only way to reduce greenhouse emission is to reduce the population of livestock. So in this case, it gave us more detail about what is the different categories of the animals, and we can implement measurements according to this classification. The second is change as animal characteristics, management or performance change. Yeah, that is really important. It is one of the advantages to moving to a tier 2 level. And the third one is change in a diet quality. Change as diet quality is showing us change into the greenhouse emissions. So we can simulate according to what we require, and all the change that we do in the different section, for example, in the different classification of animals, in the feed basket of the different animals, in the production system or the reproduction variables of the animals, then we will know exactly what are the reductions according to what is impacted according to the different actions that we were implementing in our livestock system activity. Okay, I think this is the first part, and thank you everyone for participate. Let me, okay, perfect. Okay, team. I don't know. I want to open now the microphone. Probably someone want to give some comments or some questions from yesterday, or we can continue with the workshop from today.
Thanks very much, Armando. So the floor is open for any feedback from yesterday's session, whether there's anything that people would like further explanation on, or just any general feedback. Do we have anybody who'd like to share some feedback with us, please?
I think basically it would be interesting to know if stakeholders were able to play around with the what is this, the model provided by Armando.
There are two tools. There's the dashboard, and then there's which Dominic introduced, and then there is the Gleam farm level tool that Armando introduced yesterday. And we're going to have an interactive session on that now. Has anybody managed to open and interact with either of these tools?
I think that I have a comment here in the chat saying the presentation of the finding yesterday was interesting to alarming about the significance of the sector contribution to the greenhouse emissions. The question now is how to reduce this to an acceptable level. Okay, so I think that this is part of the presentations that we have today. One of the things that reduce greenhouse emission is about applying some mitigation actions. But in order to apply some mitigation actions, it's important to determine or to observe what are the characteristics of the greenhouse emissions that we have actually, or we have now in our livestock production. So when we define exactly what are, where is the problem, for example, if we have really low fertility rates, if we have really low weights of animals and so on, then we can determine or we can implement different mitigation actions that can help us in the first, I mean, the most important thing is to make our livestock production much better. That means to improve the production, but at the same time, try to find actions that can help to reduce greenhouse emissions. So I think that that is going to be one of the presentations of today. Actually, it's going to be the last presentation. And then you will see how these mitigation actions have effect on the greenhouse emissions. So yes, we will have that today. Thank you for your comment.
Yes, thank you, Rex. That was very pertinent. Okay, Armando, I think we should get on with the the cool farm tool. Sorry, the Gleam farm level tool. So I'm going to stop sharing the poll results. I think we've done with that now. And
yeah,
Armando, over to you for this,
okay.
This next session.
Okay. Thank you, Tim. Thank you, everyone, for being present today. We have an interactive way to show you how Gleam is working, and for that we are we developed a tool that that can help us to observe what are the changes according to different parameters that we are changing in our production. So in our case, it's important to observe, and as you can see, I share now in the chat the link for the tool. If you want to open and you want to interact too, that will be good, because I will show you with my screen how it works. Yesterday, I made an introduction of what was the tool. So today I can show you a little bit fast how to make different changes and how to observe some change into the greenhouse emissions. I prepared an example at the end that I will share with a presentation, and you will see what is the utility, or why is so useful to have GLIM as a tool to estimate greenhouse emissions. Let me share screen. Okay. Please let me know when you see the screen.
See the screen.
Okay, perfect. So yesterday I was showing you what are the parameters that we require for that GLIM is using in this case for estimate greenhouse emissions. Okay, so we have at the beginning we had herd parameters, that is the number of animals of our herd. What are the death rates of the animals? But to compute the death rates, in this tool, we are asking how many animals were dying during the year, and with that we are computing automatically the death rate of cows, of bulls, at the death rate of calves, for example, as you can see here in the left side. In the middle, you can see some reproductive variables that is used by GLIM. And this, from these variables, we have the age of first calving, what are the weights of the different categories of the animals, what are the slaughter weight of the different categories of the animals, what are the meal fat and meal protein, that some, in this case, because we have a production mainly about milk, what is the meal yield in average per year in the animals, and what is the lactation period in days. In the right side, you can see that they have manure management, and how this manure management is, how the manure is managed into the farm. In this case, we have different categories, and as you can see in this example, the 60% of the manure is not managed here in the farm. That means that it's just left wherever the animals are grazing. So the manure is just staying there without any treatment. And that is a really problematic thing, because when there is no treatment about the manure, there is a lot of greenhouse emissions producing from that manure. And as you can see, 40% of the time, or 40% of the manure is managed as a solid storage. This example, it was coming from what we had for information from Eswatini. So we know that the farms, the animals are grazing during the day, but during the night they are keeping in kraals. So all this time and all the time that the animals are in the kraal, this manure is at the end just recollecting and then putting in a place where it's kept till they can use in the next session for crops, for example. So this is why 40% of the manure was concluded that is used in a solid storage. But the solid storage is even is a management of the manure is not as efficient as all the different other categories or options that we have here. For example, a dry lot is more efficient than the solid storage, for example. Making compost is efficient too, but making anaerobic digester is more efficient, because even we can have from there some energy we can produce from anaerobic digester. We can make a daily spread for the manure management, and these are activities that will contribute to reduce greenhouse emissions. And actually, the daily spread is not a difficult activity. It's just to, this manure that is on the grassland, you go with some tools and you spread the manure, and that is effective for reducing greenhouse emission, because all this manure is now just incorporating into the soil. So that is the best part about knowing exactly what are the options that we have for manure management. The second part of the options is the feeding data. So the feeding data, it's about all the feed basket options or components that we are giving to our animals. In this case, we have fresh pasture, we have silage of pasture, we have crop residues of maize. Here down you can see crop residues for sugar, and there are many options that are used by Eswatini farms in order to feed the animals. The important thing is that we know exactly what is the amount of the percentage of each feed component that we are giving to the animals, and what is the digestibility and the content of protein of that component. With that, we can really simulate what is how much of this food is taken by the animal, how much of that food is transforming into the product that means milk or meat in the animals, and how much of the food is transforming into manure. So this process is computing by Clean automatically, and this is the best part because we don't know these codes or we don't know these algorithms. With Clean, we know exactly that we introduce the variables, and then automatically is computing everything and getting greenhouse emission. That are the results that we really require, and that we need to know exactly how is our production. At the end, we have the location of the place. In this case, we have a farm that is located close to Mbabane, okay? So with all the parameters, we have a button here that is computing everything. In this example of the tool is giving result, but it's more or less how Gleam is working actually. But Gleam can compute these numbers into a country level. And this is why it's so important that Gleam was built on GIS data. So instead of, for example, in the case of this tool, we are computing what are the greenhouse emission of one farm, for example, because we know just the location of the farms. But what happens if we have to compute the greenhouse emissions of 1,000, 2,000 farms? So because Gleam is constructing on GIS, is taking all this information according to the location of the different farms, and then simulating everything and creating results for all the farms, or all the production system in the country, or all the distribution of animals of the country. So it can really make an analysis in a national level, and even further, it can make analysis in a regional level. So Gleam can compute greenhouse emission in the complete area, for example, of the south area of Africa, or it can compute in global level. That means making greenhouse emissions estimations in the world. So in the case of this study, we have here, as you can see, the results of this analysis is showing that this farm is producing 168,000 kilograms of CO2 equivalent, okay? And this can, and as you can see, the results is showing that the simulation is showing that the farm is producing per year 16,875 liters of milk, and is producing around 2,585 kilograms of carcass weight during the year. And then as you can see, it's showing the results according to the different emissions, according to the different gases. And these are calculated just the direct emissions in this case. And it's showing how what is the greenhouse emission that is produced according to the different categories of animals. So now it comes the example, for example, what happens if we want to reduce greenhouse emissions? So if we want to reduce greenhouse emissions, one of the most important actions that we can introduce into the system is to improve the data, improve the feeding quality. That means improving the pastures that we are giving to the animals, or for example, put some additional feed components with much better digestibility. If we have better digestibility in the components that we are giving to the animals, it's gonna improve. It's gonna improve the production of the animals, because we will have more animals heavier, or animals producing more milk, and at the same time is producing less greenhouse emissions. Why is that? Because the animal is not transforming, or is not wasting all the process of transforming these feed components into milk. It's more easy for the animal to transform into the production, in the production components of the animal, for example, milk or meat. And because the digestibility is much better, they are transforming much easier, and they are not wasting the energy for transforming these feed components. For that reason, it's much better for them to have feed components who have more better digestibility, and with that we have a reduction of greenhouse emissions. And I will put that because here we can simulate that, and that is the best part about this tool. For example, if we have the fresh pastures with a digestibility of 50%, 50.18% in this example, we know that probably there is an average worldwide where it's around 65%. So if how we improve the pastures, we can put new varieties of grass. We can introduce some grass mixes that will improve the quality of the grass, and with that we improve the digestibility of the component. At the same time, we can apply some measurements, for example, to the crop residues of maize, in order to improve the digestibility. One of these is to add urea into the crop residues, in order for the animals before the animals are eating that, and that is improving actually the digestibility of the component. Let's say in this case we go from 53 to 55. Let's not put too much change. And with that, we know exactly, okay, we change just the digestibility of the components, and then with the tool, we make a new calculations. And then from 16,000, we can see that, from 168,000, now we are in 109,000 kilograms of CO2 equivalent. Okay, perfect. So with that measurement, we can now see that we reduce greenhouse emissions, and we improve the feed quality of the animals. Okay, now let's make another change. What happens if we, instead of using 40% in solid storage, what about if the 20% of that manure management we transform now into dry lot? Okay, so let's see with that specific change what is happening. And now from 109,000, we have 106,000 kilograms of CO2. Okay, perfect. As you can see, there is not a change in the total milk produced, or in the total milk produced by the animals. So why? Because these variables are not modified. And I mean, I know that if the studies are showing that if we improve the digestibility of the feed components, it's not just changing the feed components, it's changing the milk yield, it's changing the weight of the animals. But in this case of this example, we can see just with the few changes that we are changing, how these are having the effect on the greenhouse emissions. Now let's say, okay, I know that the digestibility of the feed components are increasing the milk yield in the animals. So instead of having 2.5 liters per animal per day, let's say that they improve to 3.5. That means 1 more liter, okay? And instead of that, I know that now the animals are getting more weight. So now the cow's weight is not 300, now it's 320, for example. The bulls is not, well, 500, let's say is 510. The slaughter weight of the animals is not now 335, now they get to 350, for example. And in the males, instead of 55, we go to 375, okay? These are different measurements and different changes that we know that are coming from changing the feed basket. So now we compute again, and instead of 106, we have now an increase of 112,000 kilograms of CO2 equivalent. But as you can see now, the total meat produced increased too. I will show you then in a presentation with the comparison with the different values, and then you can see more clear about these results. And we know now that the total meat increased too, because now we have more heavier animals. But with that, what is important about this emission intensity? For example, we can say that in the future, this farm is having a reduction of greenhouse emissions, but because they are producing more milk, we have now an intensity emission of 4.77 kilograms of CO2 equivalent, okay? What happened if now instead of 3.5, the farm now is producing 4.5 liters per animal per day? If we make the calculations, this intensity is gained to 3.8 kilograms of CO2 equivalent per liter of milk. What is that important is that it's showing that our production in this farm is more efficient. As this number is getting lower, that means that the animal or the production system is getting less gas per unit of product that is produced by the farm. And that is showing a more efficient way, or that the farm is more efficient in the production. However, why is that really important, and why is this a value that is really good to have in consideration? Is because what happens if the farm now is putting more animals into the production? If we increase the number of animals, what will happen? We will have an increase of total emissions. As I can show you, and I can see now, instead of having 25 cows, we will have 30 cows. And from that, 20 are always in average per year in milk production. So now that they compute, you can see the emissions, the total emissions increase again, okay? Because we have now more animals, but the intensity, it keeps almost in the same number. That means I have more animals into my production, but all these new animals that are coming to my productions are coming to an efficient system. And with that, we can keep these animals in an efficient system. Why was that important? We have an example in another countries where we conclude that what is happening to the animals is that there are these farms who were coming to a project where they were putting mitigation actions, when they were implementing good livestock practices to reduce greenhouse emission and to improve the productivity of the farms. And when they were putting more animals into the system, we conclude that these animals that they were acquired or they were taking into the farms were coming from farms who were really inefficient. So that is, at least, it's good for the balance if we compare these two farms, because one of the farms that is really inefficient is reducing the number of animals and moving these animals to an efficient farm, for example, that it's keeping the greenhouse emissions of that specific animal lower than if it is produced in the farm that is not managing the feed components, is not managing the manure management, and sorry, is not managing the manure and so on. So that is important, and to have this number that is the intensity of milk in this case, and the intensity factor for the total meat. Okay, I will show you now. Sorry, I will stop this and I will show you another example. That is gonna show you the little change, and then you can notice exactly what happened with the production. As you can see here, we have the same simulation that we have now in the previous one, but with the results in the screen, okay? So when we made first the simulation, we have a production of 168,000 kilograms of CO2 equivalent. It's the total emission that this farm was producing with the variables and the that we were putting into the system. We then changed the 20% of the solid storage to dry lot, you remember? And then this number was reducing to 164,000 kilograms of CO2 equivalent. That means around 5,000 kilograms of CO2 equivalent, okay? But what is more important is that GLIM or the system is showing where this reduction was made. As you can see in the numbers from the different gas source, you can see that the reduction was in the methane from manure management, that it was transforming from 6,052 kilograms to around 4,115 kilograms, okay? And the nitrous oxide from the manure management was reducing from 5,136 to around half, 2,500 kilograms. And why is this important? Because you know exactly that, yeah, we were making change in the manure management. For sure, we were expecting results in the gases that are produced by the manure management, okay? And as you can see, the methane from enteric fermentation was not changing. And the nitrous oxide from the manure in the pasture was not changing because we didn't move that variable. Okay, but what happened now that we introduce another measurement that is that we changed, for example, now the place of the farm for the analysis. That this was a good example because the longitude of the location of the farm, we move to another sector or a different area to know exactly if the location has an impact of the greenhouse emissions. And when we compute, we can show that yes, from 164,000, it was reduced to 163,000, around 1,000 kilograms of CO2 equivalent. Why is that? Because the conditions of the temperature or the conditions of the location of the farm has a direct effect on the greenhouse emissions, because we have different temperature, we have different conditions for solid leaching, for liquid leaching, and for these variables, it's different according to where the farm is located. Give me 1 second. Okay, so what is important is that according to what I was showing, or the location of the farm, this condition is changing. So that was important for the example, and you can observe, you can play with the tool, and then you can move the farm, the location of the farm to different locations around Eswatini. And then you will see exactly what are the change that is producing this the location of the farm. Then, okay, we have what if we change the digestibility as we made in the example, and now you can see exactly that the digestibility, the total emission was going from 163,000 to around 105,000 kilograms of CO2. So that is important because here it's a huge change. So changing the digestibility has a really high impact on the greenhouse emissions, and it has a high impact not only on the transforming of the food, it has an impact on the productivity. So there are studies that are showing that changing the digestibility is increasing the meal yield, the weight of the animals, the condition of the animals, and so on. Then, as we did in the example, we increased the young males from 15 to 25. Okay, just to see, and we simulate, and then we went from 105,000 to 121,000 kilograms of CO2. And as I show you, you can see that the mid males are the ones who are now producing more greenhouse emissions in every category. Yes, because we have now more animals. But that is important because the intensity, it was in 40.75, and now it is in 36.27 kilograms of CO2 equivalent per kilogram of carcass weight. What that means, we have still an efficient system where we reduce the greenhouse emission with all the activities that we were changing, like the digestibility, we were changing the manure management and so on. So the system is efficient, and we can simulate and we can see the results here. This is the last one, is just a comparison between the first, our last measurement and our first measurement. For example, we went from 168,000 kilograms of CO2 to around 121,000 kilograms of CO2. So this is showing that, yes, we can make some change in the activities that we are implementing in the farm, and with the tools we can see exactly what are these changes. Okay, what are the effects on the greenhouse emission? But why is this so important? Well, it's simple. We can totally simulate like in a curve. So we have, let's say that this change that we were showing you, you are making every year, okay, in the farm. So we have in 2020 till 2024, for example, we implement these different changes that we were showing in the example. So at the beginning, the production of livestock, the production of greenhouse emissions in the farm has this 168,000 around, but in 2021, with the change that we have in the manure management, we have a reduction of greenhouse emission. And what happened if we would have the same production system? You can see in the orange line that is the business as usual. That means that we didn't change anything, that everything just keep it the same way. Okay, but we can, with the simulation, we can say, okay, we have a reduction for 2021 because we implement manure management actions. In 2022, we have another activity. I don't remember what was the second activity that we changed, and then we have a reduction. In 2023, we have a really high reduction. What happened? Here we change the digestibility and we implement different activities in the feed basket, and we have a huge reduction. And for 2024, we have an increase of the greenhouse emission due to the number of animals that we were introducing into the system. So we have more meat animals. Yes, we had an increase of total emissions for the farm, but compared with the business as usual, we can know exactly what is our potential of reduction, and we can show these numbers. So this example that we did now in a farm level is gonna be, or is exactly the same what GLIM is doing in a country level. but now is not managing farms. No, it's managing production system in the complete country. So it's simulating exactly what is the business as usual if no activities implementing or the system is managed in the same way, and in addition is making a modeling what happens if we implement some mitigation actions that the government, for example, has in their national plan for the next 20 years, for example, for the next 10 years. So we take these mitigation actions, we adapt to the system, and then we can simulate exactly what is the potential of reduction of greenhouse emission in the next 10 years. So this is what is doing the tool. This I hope that with this example, you understand a little bit how is working GLIM in a farm level and how we transform this to visualize what is doing GLIM for a country level. And it's good because with the tool you can interact. I mean, you can interact with the variables and you can see a little bit what are the impact on the greenhouse emissions. It's not having all the system that GLIM has as the complete tool, because GLIM is managing, for example, feedlots, is managing dual purpose production and different meal production. So is managing different characteristics for different production systems. While in this case,
wind this up now, Amanda.
Yeah, and this is just what we're showing is just an example for milk production. So this is what we want to show, and we want to demonstrate how GLIM is working and how the results are showing according to the different checks that we are putting into the system. Yeah,
thanks very much, Amanda. That's very clear, and I think this tool shows very nicely what sort of impacts can be achieved by changing these different production parameters. And this is going to help people to assess the impact of different mitigation measures. And we can see simple changes in manure management, for example, can have quite significant impact. Can I open the floor, please, to anybody who has a question for Amanda or would like to make a comment? Deepa.
Yes, thank you very much. That was very interesting. And I just wanted to ask if, is this tool, can it be given to Ministry of Agriculture, the livestock section, and can they start using it? Or is there like certain user rights that FAO holds, or is it a free for everyone to use tool?
Okay, the tool that you were seeing is just an adaptation of what the system GLIM is doing. So it's not the complete system into this example. So it's just for interaction and for a workshop in this case. So it's a free tool online, but it's not showing exactly the results that GLIM is producing. It's just for interacting and to see exactly what are the changes.
I think we could, having had a really good look at the tool now, I think it's something that we might develop into something that can be made available to people to help farm level examination of greenhouse gases and so on. Do you think that would be useful, Deepa?
Yeah, maybe there are colleagues from Ministry of Agriculture. They can also express what they feel. For me, I think what I want to say is, as part of the NDC revision process, you have used the tool. It's good for analysis. That is great. But I am looking ahead. How can the tool be used by Eswatini Ministry of Agriculture, and what exactly would be required for the tool to be used? And if that can be, those requirements can be provided, we could maybe develop proposals to raise funds to support the ministry to use this tool, because NDC revision, it just doesn't end with the revision. We need to have an implementation plan and projects developed. So maybe this can be developed into that. But I'd love to hear from the colleagues from Ministry of Agriculture, what they would, what they feel and how they would like to take this up further. Thank you.
Yeah. Any comments, Director?
Thank you very much for the opportunity. Very interesting presentation. And I just want to ride on the question that can this tool be used by the Ministry of Agriculture? Definitely yes. We need to have that one. In fact, to the ministry, it will help us to come out with decisions that we can propose to farmers in order to reduce the greenhouse gases as a country, as a government. If we can get that information, we can use it to develop strategies that will help farmers reduce the greenhouse gases. Yeah. But that one will only be beneficial to us as a government. On an individual level, we need to come out with other benefits that a farmer can get. I saw when the presentation was being made that if you improve your efficiency in terms of all those activities that are there, the farmer will realize increased productivity on his livestock, which is very good. But otherwise, we need as a government to be able to demonstrate that to a local level so that it becomes very visible for the farmer, for them to enable them to adopt the practice. Yes, we need this.
Thank you very much, Director. That's very...
Okay. I just wanted to confirm that one. I'm very excited about this. Us is to work towards making it more productive, more visible to the farmer to be able to use the strategy. Thank you very much.
Thank you very much for that interjection. Thanks, Deepa, for bringing that up. That's good, and I think we should perhaps sort of reconvene and discuss what we might like to do and what the objectives of that might be. Following that. Now we're a bit behind time, but you know, I don't want to stop discussion at any cost. So any further comments on the tool specifically? Doesn't seem so. So thanks very much, Armando. And I think there's an enormous amount of potential in that tool for people to really be able to look at what sort of impact would we have from changing these different parameters, and then what sort of interventions could be made to change those parameters. So now we're going to move on, and there'll be more about that sort of mitigation actions later on. But for now, it's back to Armando, who's going to give us a brief review of the data issues that we faced during this project. So Armando, are you going to present? Do you have a presentation?
Yes. Yes.
Okay.
Okay. Here it is. Please confirm when you can see the screen.
Yes.
Okay, perfect. Okay, so what is going to be the second part of the workshop is about the methods and guidance for compilation activity data for a Tier 2 livestock greenhouse emission inventory. Yesterday, Alessandra and Andreas were explaining a little bit about this process, but we're going to have a really detailed presentation where you can see what are the recommendations that the IPCC is doing, and the different recommendations about data collection. So to start, I want to show you what is going to be presented during this intervention. So the first one is to define activity. We will focus in the first part on define activity data needs. You will see that it requires some steps in order to clarify what is required by the country in order to present onto or to analyze and to make a greenhouse emission estimations according to what they want to present. So this is an important part before starting the complete analysis. The second part and the B part is the assess data availability and quality. So yes, we define the systems, and we have to look for information that is complementing this production system. But we have to look for information that accomplish or that have the quality that is required for the analysis. And there are some guidelines, some methods that I will show you how to collect this data. And I will show you exactly what happened in Eswatini. Then you can see a real example of how we were making that this process in the country for the estimation of greenhouse emissions that we were presenting yesterday. The third part is going to be the guidance on filling data gaps. Yes, of course, you are filling data, you are acquiring data from different sources, but at the end, you cannot find the complete data that you require for the analysis. And you will see, I will show you exactly what happened for Eswatini, because Eswatini has really good reports, really good, accurate reports that are running annually in the livestock sector. So these reports are really useful because it has really detailed information about the different production system, the different species, and the quality of the production that I think that the data is coming to the deep tanks and then is processing by the government and is showing in the reports. But however, even these reports have some gaps or is missed some information that is required for the analysis of our computing greenhouse emissions. So in that section, I will show you how to fill those gaps in order to have the enough information for computing greenhouse emissions. The next section is going to be the documentation and inventory quality assessment. That means now, yeah, produce the estimations of greenhouse emissions. And this section is going to show you what are the parameters to have a really good calculation or estimations of greenhouse emissions without losing quality in the process, okay? And the last session is going to be a continuous improvement of the data collection. That is important because at the end of every step or every process of recollecting data and processing greenhouse emissions, you always have to look for ways to improve data acquisition quality, okay? So let's start first with the defined activity data needs, okay? What is important? A tier 2 approach is recommending that you have to characterize the different production systems that you have in the country. And for that, there are different ways. You can categorize according to the different categories of the animals. For example, the region where is located, the different characteristics of the region, or you can characterize by a production system. That means if it's for meal, for meat, dual purpose, feedlot, and so on. Or you can characterize according to all these parameters, which will be better. If you make more accurate characteristics according to what is the production systems, you will have better results into the analysis. However, you will see in the next section that, okay, you make a characteristics of the different production system, but the problem is that you don't have data for that. So you have to be really careful about how much data you have according to the different production system that you are defining in the characterization of the production system here. And the IPCC is recommended that you are considering the age, the sex, the production systems, what are the animal characteristics and the feed characteristics. This is important because the feed characteristics is one of the keys for you to define the location of the areas where you want to visualize your production system. For example, and this is the example of Eswatini, we knew that in the high veld, the characteristics of the grasses and the feed basket of the animals in the high veld is completely different than in the low veld, for example. Okay, so because we have this differentiation in the characteristics of the feed basket, okay, we can define that these are two different regions where there are two different production systems. Okay, but what will happen if in the low veld we have different characteristics? Let's say in the north part of the country, in the low veld we have just the production of sugar cane, for example, and the residues of the sugar cane in that part are part of the feed basket of the animals. Okay, but in the south they are not given because there are no production of sugar cane, for example. Okay, so because we have this differentiation of feed basket in the same agroecological region, we had to define a different production system. That means livestock or cattle production that is feeding with part of sugar cane in the north part of the country and in the south that is not feeding with this component, for example. So you have to be really accurate on what how you characterize make a characterization of your production system. In this case, no, like I showed you in example of Eswatini, we define the grassland production and the mixed production. So we have two specific production systems that we define for the country. Okay, the grassland production are the ones that are just feeding with grass. These are animals who are always grazing and not receiving another component in the device into the feed basket. And the mixed production are the ones that are receiving crop residues, for example. Okay, but as you can see in Eswatini, we had different agroecological regions. We had the high veld, the middle veld, the low veld, and the Lubombo plateau. And these different characterization show us that in every of these agroecological regions, there are different feed components that are given to the animals. Okay, so for this reason, the characterization of the production system in Eswatini were 8 production system. That it was reduced just to 4 because we realized that in the high veld is the only one who has grassland production. It's just grass. Okay, and then in the middle veld and the low veld and the Lubombo plateau we have mixed production. Okay, that means that they are giving some residues of crops into the feed basket. But this was the first characterization of the production system. That is the thing. That is the first thing that you have to do as a country. And then you go further. And then when you are collecting data, this could change a little bit. So this is the first step. And then when you move forward, you will see that everything is changing probably. The second thing is to define about the activity data needs is about decision. This is a decision tree for livestock characterization. Okay. So the identify production system with different animal performance, feed characteristics is exactly what I was showing to you. And then you have to look, is there official population data of animals in that production system? For example, you made 8 production systems, okay? Then you have to identify, okay, we have grassland in the low veld. That means just grassland production in the low veld. No, we don't have animals. So that production system you have to erase. I mean, there is no reason to have that. This is why you just make a filter and you just keep the ones according to this decision tree that we have here as an example. And this is into the guidelines that I can share here with the presentation you will see and you will have in the future with all the guidelines of how to collect data. Okay, if there is no animals, are there alternatives data sources to estimate population of animals? that means probably your point of view is that there is no animals in that production system. So you have to look for information that will show you that probably there are animals or there is population in that production system. If no, then you have to totally check again if that production system is existing or not. Otherwise, you just characterize, you just have the population of animals, and then you have to look for information. Is there official data on key animals performance or feed characteristics for that specific production system that you want to define? Okay, if you have it, yeah, okay, you have a specific production system that you define for the country, for example. But if not, then you have to check for alternative data information that make you establish that this production system is existing or not. Okay, and for sure, the important thing is that everything is with a timeline. Okay, because sometimes, like I showed you in the example of the tool, the farm tool, if you want to show what are the greenhouse emissions in a period of time of 10 years, you have to look for information about 10 years behind. For example, we wanted to compare and we want to see what are the greenhouse emissions for Eswatini, and we realized that you have these livestock reports from the country every year since 2011, I think. Yeah. So this is a good source of information that you can get to those reports, and you can totally see what happened during the time, during the different periods of time with the livestock sector production, for example. And yes, because of these reports, we realized that in 2015, you have this El Nino problem into the country, and the livestock population reduced drastically. So exactly, this kind of reports and this kind of data that you have to in a timeline will help you to show and to estimate the greenhouse emission according to what you require. And this here is a technical definition of what are the IPCC activity data parameters that are required for estimate greenhouse emissions. One of them is the population, the number of animals, the different weights of the animals, the body weight, the live weight of the animals, the live weight of the mature animals, how much weight is gaining per day the animals, what is the body weight at 1 year old. This is one of the requirements that the IPCC recommended, that you should collect this data. What is the meal yield of the animals? For sure, you need to have that in order to compute greenhouse emissions. What is the fat content of milk? What is the fraction of adult females giving birth, for example? Okay, these are parameters that are helping you, and there is a list of parameters in these guidelines that that I will share with you in this presentation, showing what are the specific data that you require for making estimations for greenhouse emissions. We have the fraction of females giving birth to multiple offspring, this in goats and sheep, for example, because this analysis is not about cattle, it's about the different species, goat and sheep, that are producing greenhouse emissions too. What is the feeding situation? Like I said, what are the components of the feed basket? In case of you have drug animals, what are the worker hours of the animals, for example? We have the feed digestibility, as I was showing you in the example of the feed basket of the farm glean tool. What is the fraction of manure that are managed in the different systems? As you can see, in the tool, you can see that we have most of these variables, and we were introducing a little more to identify different characteristics of the production system. But in these guidelines that that the IPCC is recommending, they are showing exactly what are the parameters that you require for making an estimation of greenhouse emissions. And then, yes, the mean annual temperature of the place, the crude protein of the diet and the protein content of milk. Yeah, these are variables that are required to collect from the data. So these parameters are you define the production system. Now you know exactly what are the parameters that you require to collect from this production system. Are you able to collect this data? Are you not able to collect this data? How you collect this data? This is the part B, okay? And the thing is that, we have to prepare a spreadsheet to record all the available livestock activity data. And in this case, you put the production system, the agroecological zone, the region where it is, and then all the parameters that we were selected in the preview that I showed you in the previous slide, okay? And with that, the second part is to identify stakeholders, okay? So you said, okay, I need to collect this data. Who are the stakeholders from the government that will help me to acquire this data? Okay, the Minister of Agriculture, the Minister of Environment, for example, the different local governments from different regions, for example, they have additional information. Livestock operators, research institutes, and different institutions that can help you to provide with this information in case that one of the other organizations or government areas cannot provide, for example. But what is the best way? There is this example of this recommendation called a snowball approach. What that means, you identify 2, 3, or 5 stakeholders, key stakeholders, and then you ask them to recommend who will have additional information. Then these stakeholders are giving you more contacts of different organizations, of different government areas that will provide you with the information. Then you ask these people for another contacts, and then you go really deep into like a tree and just collecting these contacts of these people who will help you to collect this data, okay? The third part of C data availability is to collect and record in a spreadsheet to identify the livestock data activity data. So that means, for example, you want animal population, and then you have, okay, we have national accounts, we have a human population census, agricultural census, livestock census, and so on. So you start to classify the different source of documents, for example, from policy, from research papers that you have online, for example, from public reports that the governments are putting. And then we call like a gray literature that are additional reports from different other organizations. So you list all of them, and then you just classify and say, okay, this variable from here, probably I will get from this document. And then you just classify and make a really interesting and really detailed matrix when they are showing where you are collecting this data. Why is that important? Because with that, you will exactly know what are the information that you have from the reports and what is the information missed. That is going to be the next step, how to fill these data gaps. Okay, and then you have to access the quality of the data that you are collecting, okay? So with that, you make a livestock activity data quality where you show this information is transparent. That means it comes from official sources and so on. It's accessible. That means I can access to this information easily or not, or I need to require with an email or with an official document to the government and so on. If this data set complete is showing all the parameters that I require, is consistency and comparability. That means I can compare the units that are showing this report with the units that are required by the IPCC in order to estimate greenhouse emissions. These are the questions that we have to do, because if it's not, then we have to adapt this data set. Okay, if this data set is accurate, that means it's from the statistics is showing really accurate data or not. Okay, it's not it's not sampling. I mean, it's not just a sample of a specific area. It's a complete data set, or it's just a sample of a specific region or location, and then we have to adapt to know exactly how to make this data set for the complete country, for example. And for sure, it has a timeline. That means it's collected this data set in different years, and with that, we will know exactly, like I showed you before, we can make the measurements in the past and in a period of time according to what, as a country, we want to show in the greenhouse emissions. And I said, no, Eswatini has a really good reports. This annual report from the Department of Veterinary and Livestock Services, it's really good quality data. And from there, you can extract most of the data that you require for this. But not all of them, and I will show you what happened in the next section. Here is the section about data gaps, and then how you fill data gaps. Okay, so for example, you have different variables. Okay, in different regions. For example, in the Highveld, you have one variable of animal weight, and in the Lowveld you have the animal weight, you have a number for animal weight, for example. But you know, in the middle well, is like the middle, is like the transition between the Lowveld and the Highveld. So then you can make an interpolation. You have these two values, and then you can say, okay, the middle value is going to be like an average of both of them. You have an extrapolation. What is an extrapolation? You have the Highveld, the middle well data, variables for weight of the animals, and then you want to compute the Lowveld, but because you have for example, you know exactly that there is a trend that is showing that the animals, according to the altitude, is decreasing the weight of the animals, for example, then you can totally extrapolate that the value of the Lowveld is this value. These are examples that I can show you, or I can explain you, then you can understand what is interpolation, extrapolation. Use of surrogate data. What is surrogate data? When you have two variables that depend on each other, and then you can calculate one variable according to the value of another variable. Then you can combine multiple data sources, and in last case you have the IPCC default value. So you can, you don't know exactly what are the value of the data set. I cannot find the value of data sets. Okay, the IPCC, it has default values that you can use. How to collect new data and fill data gaps? Well, you can make surveys, or you can make expert judgment, and that is one of the things that we were making in Eswatini. We have an expert judgment that were analyzing all the data sets that we were collecting from different sources, and then they were corrected. They said, okay, no, in the Highveld is not, for example, 270 kilograms, the live weight of the adult cows. It's around 300 kilograms. So they were collecting, they were correcting parameter by parameter, and then we were making in two workshops, and it was a good activity in order to have or to fill in these data gaps that we have. Then what is the next
Amanda,
part?
sorry to interrupt, but I think we need to wind this up now.
Yeah, I will finish. Don't worry. The last part is about the documentation and inventory quality assessment. Okay. Now you made the inventory. You know the data sets. You know you made the calculation and the estimation of greenhouse emissions, and then you have to make to show that with documents that it was transparent, that the quality is good of these calculations. You can verify that the results that you are getting are according to different source of estimations of greenhouse emissions, and so on. And then the last part is gonna be the continual improvement. So what I want to show here is that yes, we made a different process. We collect data, we go to the documents, official documents, we make this expert judgment that they were analyze the data. Then we even make a quality verification in some farms in order to know exactly that this data set is accurate. But in the future, what is the best way? Well, you have a really good system in Eswatini called the deep tanks, where all the animals are moving. If you start collecting the data that you require for the inventory in the deep tanks, and then actually they are locations. I mean, you exactly will know even where what is the live weight of the average of the animals in these different locations that you have in the deep tank, and it will show you and will help you to improve data quality in the future in order to make the process more easy and more accurate, because you don't have to depend on expert judgment and so on. So these are the things that I want to present to you. Thank you for this, and I hope this presentation help you to understand a little bit what is the process of data acquisition.
Thanks very much, Armando. And that's a very, very, very important aspect of this project, and the report will have detailed recommendations of how we can improve data collection in the future. So quickly opening that up for comment and discussion from the floor, please. Raise hands or just speak out. There are not too many people.
Yes, Deepa.
Deepa.
Okay, it was very interesting presentation. Thank you so much, Armando. Mine is not a question, it's just throwing some ideas to the floor. One is on the data. I wonder is it possible to have data publicly available somewhere in a website, maybe hosted by Ministry of Agriculture, so that it promotes more and more research in future, and just like we keep updating every month or every 6 months or whatever. Just to throw that question to perhaps the director and others at Ministry of Agriculture. Then second one was, as we were looking at this, yes, we are focusing on greenhouse gas emissions, and our aim is to reduce emissions from the livestock sector, but also not to forget the other social dimensions of the livestock sector. I can see that from the DPM's office, the gender department, Pendulo is in the call. And I was wondering if also, just outside this study, but just in general, to look at gender and livestock issues, because it was said on day one that livestock is the wealth for Eswatini. Are women owning livestock? I don't know. Is it allowed for women to own livestock, have the decision-making power to use the animal products and sell them, and while maybe they are the ones who are doing quite a lot of the bulk of the work. So those are some things we can think about maybe in future if we want to come up with some projects for the livestock sector. So just a few thoughts. Thank you.
Thank you, Deepa. I want just to give a few comments. We have different projects in other countries where we really have to characterize the production system according to who is managing this, if it are women or men, and it has really, really good impact, because when you identify who exactly is managing the livestock sector in different regions, when you are training or when you are giving support to this production system, you have to go for the person who is managing that. And with that, just with that identification and with that study to know exactly about the gender into the livestock, we could have really good results according to how the people were applying the recommendations that we were giving as a project. So yes, it's totally good. I totally agree, Deepa. It's a really good comment. Thank you for that.
Thanks a lot. And just to have a new voice, can we hear from Voice Malima?
Thank you. Just to respond to, I'm from the Ministry of Agriculture. Just to respond to the question on the availability of data, we actually, the reports that were put up there, including the census data and the annual reports, are actually put on the department website. Unfortunately, it's not very discoverable. So it is available to the public, and we often try and get people to have easy access to it. Unfortunately, the design of the website doesn't facilitate easy discoverability of the documents online. So you have to actually get the URL from someone who actually knows. And secondly, to respond to the question on gender diversity in terms of the livestock projects, most of the projects are owned by women in livestock in the rural areas. And I think if you were to check on the women farmers, there's a program that is actually run in the country, women farmer prizes that are actually set to promote it. And they are a lot of women who actually own successful livestock projects. But unfortunately, when we collect the data, it doesn't actually reflect on to whether the owner of a specific project is a male or a female. And there could be within the same homestead a number of projects that are owned by different people within that particular homestead. Thank you.
Thank you very much, Voice. That was good to hear from you. In the interests, Ali had a question, but I see she's put her hand down. But I think in the interests of time, and apologies for the delay, Aimable, but we'll hand over now to Aimable Louisier, who is one of our team, as I think you mostly know. And Aimable is going to walk us through the mitigation actions for the livestock sector in Eswatini and some recommendations for next steps. So, Amanda, if you stop sharing your screen and allow Aimable to share his, please.
Yeah.
Over to you, Aimable.
Thank you so much, Tim, for the introduction. Let me share the screen. Can you confirm that you can see the screen?
Yeah.
Yeah, perfect.
Very good. So let me put this to. Yeah, thank you so much for this opportunity. So I'm going to try to talk about the mitigation actions for the livestock sector in Eswatini and some recommendation on the next steps, mainly regarding the modeling that we are conducting. So as Tim said, I'm Aimable Louisier. I'm a livestock policy officer in animal production and the health division of FAO. Let me start this presentation by highlighting the objectives of this. So the idea here is really to make sure that you understand how to design and implement mitigation options in national programs and policies. So as an outline for this presentation, I will give you some background on climate change and why it is important to deal with climate change in agriculture and especially in the livestock. And then I will move on by talking about what is a mitigation, how to design and implement mitigation options. And we will discuss some mitigation options that are possible for Eswatini, and we'll end up by some take-home messages. As a reminder, we know that climate change is affecting agriculture in different ways. As discussed yesterday, the issue, for example, of El Nino, which is one of the extreme events that affect agriculture is particularly of interest in Eswatini. So we know that climate change is mainly increasing the temperature, is changing the precipitation patterns. The climate change is increasing the occurrence of different extreme events. And also that has a direct effect to the farmers, because we know that most of the low-income farmers around the globe are the one directly affected by climate change. So meaning that climate change is really a serious threat for the food security and for the sustainability and profitability of different farms around the globe. And that's also, I think, it applies to Eswatini. On the other hand, we know that, of course, agriculture contributes to the climate change in different ways. So now we have been discussing since yesterday about livestock, but the big challenge is not about mainly the current emissions. The big challenge is about how do we feed the growing population in coming years to come while we reduce our environmental footprint, mainly reducing the greenhouse gas emissions. So, and you can see that when you look at globally, you see that agriculture, of course, is also a large contributor to the greenhouse gas emissions. But looking at the inventory of Eswatini, as you saw yesterday, the livestock sector, especially the Untitled methane, is one of the largest source of emissions in Eswatini. So then the question is, how then do we make sure that the different development programs in the livestock sector are being implemented while we keep in mind on the approaches and techniques to reduce the emissions? So I'm going to present this by really looking at the inventory and how we estimate emissions, and showing you how from different perspectives the mitigation can be implemented. So then one question is then, what is a mitigation? So it is evident that there is a direct relationship between the increasing temperature and the concentration of greenhouse gas in the atmosphere. So meaning that any action to reduce the concentration of greenhouse gas in the atmosphere may reduce the effect of climate change. So mitigation, according to the UNFCCC, refer to the efforts to reduce emissions and enhance sink. This is very important because you know that agriculture is a source of emissions, but it's also a sink. So I'm insisting on sink because that is one part that usually is ignored, because usually it's difficult to estimate the sink, but I will come back later on the sinks. So let's look at then what have been discussed since yesterday. So first is the tier approaches. So if you use tier 1, how can you reduce emissions? I think Armando said that this morning. So the only way you can look at this is either to increase the sink, so how the current emissions are being captured by the natural sources, mainly the soil or the forest. So mainly capturing the carbon from the atmosphere. Is maybe you can also change your emission factor. Unfortunately, changing emission factor is difficult because the emission factors are kind of standardized by the IPCC. So therefore, it's not easy to change the emission factor if you are using tier 1. So the big option that you just have is to reduce the animal population. This is very critical because sometimes most of governments and especially farmers, they are not willing to reduce the animal population for different reasons. So because usually the animals serve as their social capital and their financial asset. So reducing the animals is making them poor. So therefore you need to look at on different approaches. So let's look at how you do that, of course, if you look at a tier 2. In the tier 2, it's a very elaborated approach, as you saw since yesterday. However, you have many possibilities. Let's look at what you can do here. So for instance, if you look at the beef production, there is a way to look at feed intake. You can manipulate the grassland management. You can increase the feed digestibility. You can use several additives that can inhibit the methane production, for instance. You can improve the performance of animals through the genetics and improving the fertility of other animals, as well as that, of course, will have a direct consequence of live weight. And the other approach would be a way to reduce, of course, the loss of energy. As you know, most of the intake, especially the feed, provide the energy to the animals to do different activities. So you can, once you improve the net energy that you get after the digestibility, of course, that also can improve your emission. The other way would be to improve your emission factor. Of course, that's usually is very difficult, as discussed yesterday, especially that in developing countries, we have less resources to provide country or location specific emission factors. So then one point is then how do we design and implement mitigation options? It is important to know that mitigation options need to be formulated and implemented through national programs. They cannot be just some activities done by a few farmers or just done voluntarily. So they should be implemented through national programs, and those national programs should elaborate mainly technical measures that need to be implemented to mitigate climate change in livestock. So they can also be implemented in different policies or incentives or some investment programs. For instance, if you look at this figure I put here, it shows you that if you put a mitigation, you can reduce, of course, the concentration of greenhouse gas emissions and the effect of climate change. But mainly some countries tend to emphasize more the adaptation. And you read that mainly in different nationally determined contribution. However, you need to keep in mind that the adaptation doesn't reduce the emissions specifically. Sometimes the adaptation actually may increase the resilience of your herd, your livestock, but they may also increase the emissions and they continue to increase the climate change. So the effect, especially those events that I described at the beginning, may be the one actually you will see often as we move toward the future. So therefore, it's important to combine both. So how you increase the resilience of animals and farmers to the climate change, and how you reduce the emissions. So it's really important to keep that in mind. So then let me jump a little bit on one aspect. So here I'm presenting the cattle population, so which has is the growth rate of these systems in Eswatini. The cattle population decreased annually at a rate of -1%. Of course, that's very problematic. For instance, in the last 20 years, 30 years, the cattle population reduced almost by 40%. This is quite huge. So therefore, the question is what the government can do. So one of aspects is need to look at the different development and investment strategies. So that can improve the productivity and the production, that can increase the farm income, increase the meat export, as Eswatini is one of the countries that can export some quota of meat in international markets. It's a way to look at how livestock can contribute to the reduction of poverty while it improves nutrition. Of course, this is very important because if you continue to do business as usual, the population of cattle will continue to decrease in the future. However, looking at those strategies that can support the development, so especially a strategy that I put just arbitrarily at 1 or 2, you can see if you want to maintain the current herd or you want to increase the herd. So, and then what how do you do that while reducing the emissions? So here is a very interesting figure that I want to show you, because methane is one of the biggest source of emission in Eswatini, and it's good to understand how methane is produced. So methane is mainly produced through the digestion of carbohydrates in the rumen of animals. So mainly is a combination of different factors, mainly the bacteria, fungal, or protozoa that contribute to the fermentation of any carbohydrates consumed by animals, which is very important because this process produces the different fat acid, the acetate, propionate, and butyrate, which are the main sources of energy for animals. However, on the other hand, of course, you have an increased production of methane. So the big issue then is, how do you deal with this? Because animals need to continue to be fed, and you need to make sure that the emissions are reduced. So let's look at how we can do that. So first I want to insist on methane because the main source, as you saw, methane is a short-lived climate pollutant with a lifespan of 12 years. Of course, any effort to reduce methane emission in livestock will have direct benefit to the farmers. However, of course, we need to see how that is done. So let me show you, ask maybe some questions here. Maybe I can stop here a little bit to ask, and let me remove yeah, so here I have one question for you, is to see what option would you consider to reduce enteric methane while increasing productivity and profitability. So I'm going to stop sharing the screen because I want you to reflect, so you can maybe put some comments in the chat or just take the floor and share your thoughts. And then we will go through what you were sharing. So the question is, maybe I can copy the question and put that in the chat. Then 1 second, the chat is here. Okay, so now you have the question. So what option would you consider to reduce enteric methane while increasing the productivity and profitability, especially the farm income in Eswatini? So the floor is yours. So if you can type in the chat, that would be great. So I can see Deepa say improve feed quality. Any other comment, please? I think everyone should type in the chat. So please type in the chat, we can see. Yeah, so use of seaweed, that's very interesting because seaweed has a very good, let's say, impact because it can reduce up to 82% of emissions on enteric methane. Unfortunately, the seaweed is not yet available on the market, but it's a good technology, let's say, that is being explored in research. And to decrease the number of no productive animals. This is very interesting. However, you need to keep in mind that the role of livestock in the community is important. So therefore, reducing the animal numbers may not be quite easy because the community needs to understand what would be the alternative, especially when it comes to keep to the financial asset or to the social value of livestock in the community. So it's really a process that requires the government and different discussion with the stakeholders to make sure that there is an alternative. So I see Dex say that the simplistic approach for the bulk of our livestock is to improve the quality of overgrazed grazing through regenerative catchment management. This is a very important aspect. Of course, I would say that most of our livestock are on grassland or rangeland, and usually with one key aspect that the rangelands are not managed. So therefore, the animals are free in the rangeland. Sometimes that leads to the overgrazing and to the land degradation. So meaning that the improvement of grasslands it's really important. So I see forage quality, Leslie, that's good. Regenerative catchment, yeah, that's very interesting, because I think the regenerative management has also several benefits, especially on biodiversity and on soil, especially on soil sequestration. So please type. I expect more. Please. Any other contribution? Okay, so yeah, this is very interesting on animal health because there is a need, of course, to invest on animal health to make sure that animals can produce to their best potential. And animal health is one of the aspect that we call no regret options, because it's an area where all countries currently agree that in terms of livestock, sustainable livestock, animal health is an area where all governments at least agree on how to improve the livestock management. So I see that maybe we can stop here. I encourage you to continue to type as I continue with the presentation. If you disagree with one of the approach that I'm going to present, please type, because it's very open, and we want, of course, to make sure that you all contribute to that. Okay, let me back to the presentation. So yesterday, Alessandra presented some figures showing, of course, the different emission profile of animals. And you can see that without looking at the numbers, but mainly looking at the profile, you can see that the emissions, especially the enteric fermentations, are very important. And they are mainly coming from the adult male and the adult females, especially from no producing animals. So therefore, it's very critical that we really deal with enteric fermentations. So I'm going to navigate through some options here. So first, let's look at one is how do we improve the efficiency? Looking at the national data, we found that mostly the fertility of animals in Eswatini is very, very low. So therefore, while there is an aspect that, for instance, the decline of the herd is mainly due to other external factors, or somehow how the herd is managed. The infertile animals are quite many. So you have a large population of adult males that are not producing, and you have also the adult females that are not producing. So maybe looking at how artificial insemination can be used and how to reduce, of course, having a good breed of animals, and how to reduce the interval of calving can be one of the options. The second option is to improve the feed resources. So improving food resources is important, because I think that goes to the comment that Rex put in a comment about the regenerative grazing. So it's important to make sure that the animals are contributing to the maintenance of our landscape and our grassland. Therefore, they need to be managed, not left alone on highly concentrated on grassland in a highly concentrated numbers. So the other way is to look at how to increase the forage quality. So mainly, I saw that some farms, especially specific dairy farms in Eswatini, are growing grass or a different type of forage, and it's the best way to improve, of course, the quality of feed, increase digestibility, and reduce enteric methane, because high starch forage decrease a lot the emissions. The other aspect is the feed digestibility, and I think Armando insisted a lot in his in the demonstration of the tool, so I won't go much more in details on the digestibility. So then let's look at the offset. Offsets is any approach to remove the emissions, or to remove the emissions from the atmosphere, or to prevent the future emissions. So here, one of the offsets, it can be the biogas. Biogas, why is an offset? So it contributes first to reduce the emission of methane in manure management. However, it replaces also, it is a good substitution of electricity and other source of energy in the household. Therefore, having a biogas plant in the farm can help to the expenses that farmers spend on external energy sources, especially from national grid. But also, it's a very best way to have a good organic fertilizer, because the digested from the biogas can be used directly on fertilization of different cropland. The other aspect is the soil carbon sequestration. So the soil carbon sequestration is one of the approach that is being looked a lot in agriculture on how to leverage and offset the different emission, even from other sectors, especially from energy. However, it's not easy. So because you need to improve the soil management, you increase soil health, maintain the biodiversity. So it's really a very slow process of offset, but it's an approach that any country can, especially Eswatini, can use to offset the emissions. So the aspect of offset means actually that if I continue to emit in one sector, the emissions, I may use another sector to recapture or to remove the emission from the atmosphere to make sure that the net, the total of those two activities are zero. So it's what is usually referred to as net zero. So then, as I said, the other aspects, when you look at the head structure, we have really a large number of oxen in Eswatini. And this is very problematic because those animals are contributing a lot to the emissions, while they can really be well managed by, for example, using a different alternative mechanization on farm, or really looking at how to leverage the financial asset or the social capital that farmers always hold for usually cultural reasons. So I came from Rwanda and we used to do the same, but now I think farmers have really understood that having productive animals and being oriented to the market is better than having no productive animals that consume a several quantity of natural resources. The other aspect here is to use sexed semen. So when you use sexed semen, of course, usually they are females. So you can use this technology as a way to reduce the number of male animals in the population. Therefore, that will in the long term really increase the productivity of the herd in the future. So of course, it's important to keep in mind the socio-economic role of cattle systems in Eswatini, because without doing that, of course, this is, I think, one of the key aspects, because livestock play a big role, especially on socio-economic and cultural role in Eswatini. Therefore, using mitigation, reducing the emission is important to maintain this role in the community. So of course, I think this is a bit summarizing all that we discussed. I saw that also from the different reports that there are some feed roads that are being started around in Eswatini, and I think feed road is good, but when it's not well managed, it can be also a big source of emissions. But I think it's an opportunity, for example, to increase productivity in the beef sector. So to finish this, let me sum up some key messages. We know that ruminants play a key role in food security and the livelihood of farmers, especially in Eswatini. We know that the main source of emission is the enteric methane. And of course, the structure of the herd and the opportunities that the government are putting in place are providing kind of a good let's say, good opportunities to mitigate. So this mitigation can be done through some short and medium term, especially to reduce emissions, or through long-term strategy to increase the soil carbon sequestration, especially through the regenerative grazing. And of course, it will be important once we deliver on this project to look at maybe in the later stage on the cost and benefit of different interventions, because so far we are analyzing those mitigations to see what are their potential to reduce emissions. But in the future, I think it will be good to look at the cost benefit, because this is important to convince farmers to adopt. So of course, overall, while the inventory look at their own farm, let's say the direct emissions, it's important to look at the sector in a holistic way, especially looking at the different dynamics on supply and demand, and how the future, what are the future objectives of the government to make sure that the mitigation options are in line with the future objectives. Thank you so much for your attention. Over to you, Tim.
Thank you very much, Amable. That was very, very useful and clear overview of mitigation options and actually how they will work. And it's quite clear to me that that there are many what we call no regret options, where we can improve efficiency of production, and there should be no additional costs overall with respect to the benefits that are achieved. So open the floor again to comments and discussion. And we've actually had quite a lot more feedback in the chat about options to reduce methane emissions, and a lot of the more recent ones have talked about breeding and selective breeding and selecting for genetics that are low emitting. There's a lot of variability amongst individual animals, and some emit a great deal and some emit much less. So moving towards animals that tend to emit less is one of the ways forward. So please, questions, comments for Amable. Please either raise your hand or just shout out. Amable, what do you think, having studied the herd structures and the emissions in quite a lot of detail for Eswatini, what do you think the main opportunities are? Where do you think if you could just choose one thing that could be done to make the biggest impact, what would you say it is?
Of course, I think one of the biggest challenge is really to improve the fertility of the cows. Because when you look at the data in terms of calving, the rate is very, very low. And of course, we have been discussing this because when you model this and you look at the projection in the future, you see that the herd is declining on any case. And this is very problematic because if the different programs and policies are not really addressing the issue on how to improve the productivity of the animals and maintain a population that will supply enough animal source food for the population, that will also meet the different quota for export that Eswatini has, especially on different markets, that would be very, very problematic. So I think that aspect would be provide good co-benefit, because they will mainly improve the productivity, but it will stabilize the herd, because now the herd, of course, we acknowledge also the different issues that have been in the past, especially the El Nino effect and so on. However, it's a good moment to make sure that the population is recovering from those type of events, because otherwise, Eswatini may, in the future, under the business as usual scenario, depend only on imports for their meat consumption, which would be very, very bad for the economy, because you should really avoid increasing the foreign exchange balance. So that's what I think as maybe the biggest opportunity to improve in the herds. I'm talking about mainly the cattle, because they are the biggest as compared to the small ruminant.
Yeah.
Over.
Thanks, Amablet. Rex has been putting a lot of comments in the chat here, which is to do with the just too many animals. Breeding interventions might work in professionally managed herds, but the SNL herds are openly grazed and difficult to manage. And do you want to expand on any of that, Rex?
Yeah, sure. Can you hear me?
Yes, thank you. Yeah.
No, there are there's herds on SNL, the Swazi Nation land, the common land, of which I'm sure is 3/4 of our herd. They graze openly, randomly on land that is overgrazed and unmanaged. The breeding side, I'm not an expert in this, but on the breeding side, there's no controls over who breeds with who or when. Those herds that are managed professionally, commercially, certainly there are controls over the breeding and the genetics and the fertility and so on. But I think that represents less than 1/4 of the million or 800,000 head of cattle. The bulk of the cattle are just grazing and destroying grasslands and offer little or no benefit apart from to the owner who has to, or who enjoys having a quantity of cows to show off his wealth rather than the quality of those cows. So there's any mitigation or adaptation has to be separated between those that are commercially orientated and look after their herds, and those that are just national herds grazing openly unmanaged. The other problem I've had with the livestock is the amount of money government gives support to this sector. If I own a car, I pay road tax, I pay taxes on petrol, I pay taxes on the car. You own a cow, you don't have to pay anything. You get free grazing, free medical support, free dipping. You're just sustaining a problem with no benefit apart from to the owner of that herd who may sell. But yeah, livestock are a big problem for me. They cause too much damage and they're pretty worthless.
Thanks, Rex. That's some fairly strong words about the situation. Does anyone want to respond to that?
Yeah, maybe I can comment on that because I think the situation of Eswatini is quite common when it comes to the different systems that are on agro-pastoral lands, where especially the animals use the community land. And of course, the issue there is mainly about the traditions, because usually farmers keep, the reason farmers keep the animals is really for their social and financial insurance, they say, which usually is not in line, of course, with on aspect of sustainability. Of course, that value that they produce, which is very important for the community, usually is overlooked when we look at the emissions and the emission intensity, because we don't capture that into our emission intensity because we look at the productivity. Therefore, one of the aspects, of course, is to make sure that the farmers can continue to keep their social and capital insurance, while, of course, those animals are producing. That's one of the challenge. And of course, it depends on how the government is willing to design those incentives, because of course, in many African countries, it's not that only for Eswatini. In many African countries, you see that the government provide incentive, especially when it comes to animal health, when it comes to the access to different lands, especially the government lands. But it would be important to make sure that those animals are also integrated into the productivity. So, of course, I would say not maybe be a bit radical saying that those animals are useless or they are not productive, but I would say the value that they provide is quite different. And then there is one point that Dex, you mentioned, is really the quality and how you manage those animals on communal land. So I think that's one aspect that maybe government should start looking on, because I saw that in Kenya it's the same when animals are on those community land. Any action that kind of put some order on how to use the community land and so on, how to organize. Farmers always, they oppose because they think that once you start doing that, the idea is to take the land away in the future. So they really see that as a threat. So mainly I think is how you organize those communities to make sure that the idea on how to improve also is owned directly by them, not is imposed. Because when it's imposed, it doesn't work. So it's a very aspect of anthropology that I'm not an expert, but I think where we need really to think about how to address that on a social perspective.
Yeah, I think it's all about creating the right incentive structures and finding out what the issues really are to improve productivity. Alessandra, you've had your hand up.
Yes, I have a question that is, related to the previous intervention and on the fact that I heard that the communal land is a big share of the land in Eswatini, and that Amable mentioned that soil carbon sequestration is probably the only intervention that is a seek for CO2 emissions. So I'm wondering if Amable or someone else, some Kellens with the or other person in the audience see intervention and the soil carbon sequestration as a good mitigation action for Eswatini.
Thank you, Alessandra. Does anybody from Eswatini want to respond to that?
Hello.
Hello.
Yeah. Good day.
Good day, Thapelo.
Yes, mine is just a follow-up comment on what has just been said by the previous speaker. I think it was Mr. Rex Brown. I think basically we need to balance the benefits of livestock production. We know very well the benefits of livestock production to our livelihoods, and balance that with the need to also consider the climate change issues. So it wouldn't help maybe to concentrate much on maybe reducing the livestock numbers. Consider the problem first before maybe you try to solve that particular problem. What I'm trying to say is, if you can maybe look at even onto the sustainable development goals, the one for 2030, for instance, they take into consideration how we can reduce the impact of maybe livestock production to climate change, as well as improving the production of these animals, because they also play a critical role in the development of the country and the livelihoods of the Eswatini per se. Thank you very much.
Thank you very much. Deepa, you had your hand up.
Yeah, I think Thapelo kind of took the words out of my mouth. I was just going to say that let's not forget the contribution of livestock to poverty reduction. And while we think so much on reducing emissions and mitigation, let's remember that owning livestock is a huge climate change adaptation measure. And so when we look at a household level, we can't be so privileged to talk about, it creates emissions, so let's get rid of it. That would be just a very wrong approach to look at it. We have to take it holistically and then look at the sector and then see what measures we can do to improve it and reduce emissions. But yeah, thank you.
But of course we always shy away from that because it makes the problem a much bigger problem, and it's not just a technical problem in livestock production. It's a whole societal problem that needs to be addressed. So so I think it is complex, but it does need to be addressed. And I see, Rex, you're saying that there's the bookshelves are full of reports on how the national herd should be made better, but none get implemented. And we need to find out why they don't get implemented and address those problems. So it's and as Amabla has said, it's a very common problem in many areas. Changing incentives. Any other comments? We're a bit delayed, but this has been great because we're having a nice conversation. And I think the two issues that we've been addressing today are really about the data that are needed to estimate emissions and to report emissions is essential. And thinking about what we can do to actually tackle these emissions is also essential. So that, you know, these really are at the crux of the matter. So it's very important that we cover this ground thoroughly. Do we have any other interventions? No? Okay. Now, thanks all very much for staying with us. Now, if I go back to the agenda, it's for me to close the workshop. Well, not for me to close the workshop, but to come up with some closing remarks just now. So I think it's been very useful workshop. You know, we've covered all of the ground. The project has been a bit delayed, but we're still tying up the loose ends of collecting the best data and analysing it and going back to through Sam Kelly, going back to the people in Eswatini to answer questions about the data, to improve the data. So we're working through all of that, and the final report will be available in the coming weeks, and this will have details of all the analysis and so on. When we have the sort of final data set, I think the dashboard that Dominic showed us yesterday will also be made available to everybody to play with, and we'll begin discussions with Armando to think about the tool for looking at individual farms as well, so that people can really use that to explore what sorts of impacts will be achieved by different interventions and can actually model them themselves. So with that, we're hoping for somebody from the Ministry of Economic Planning and Development to close the workshop. Now, is Ms. Sibonile available?
Amiso, is Sibongile with you? Amiso? Let me just quickly.
Thank you, Deepa. Can I come in on behalf of Sibongile and the acting chief, Mtunzi? As a Swatini, we would like to convey our sincere appreciation to FAO, the UN Environment, and the Climate and Clean Air Coalition for supporting this capacity building session on the mitigation assessment and options for the livestock sector. Actually, from yesterday, I think we've seen a really good mix of presentations, discussions, and surveys, and it has been very interesting for us as the participants. It's also very encouraging seeing the livestock sector having been well represented since yesterday, and they are meaningful contributions. I think we've seen them making really good contributions in terms of integrating sustainable options also, especially on the part of integrating SDGs into the whole issue. And our sincere thanks also goes to the NDC partnership for supporting the ongoing Eswatini NDC revision exercise which has been facilitated through the Climate Action Enhancement Package. Let me also take this opportunity to appreciate the participants for their unwavering commitment to attend and participate in this training since it started yesterday. Special thanks goes to the trainers and the facilitators that has been helping to conduct the training. On these remarks, I would like to again say thank you on behalf of the Acting Chief Economist.
Thank you very much. And all that remains for me to do is to wish you a good afternoon, and so look forward to being able to share the report with you and to continue to collaborate in the future.
Thank you very much. Bye, everybody.
Thank you. Bye.
Thank you. Bye bye.
Bye.